So I'll open up everything again. Why is my processor running so fucking heavy? Okay, so that's that guy. Okay, so this guy here. Okay, so the maximum amount of time allowed for this task is 10 milliseconds. If it's not complete in 10 milliseconds, which is 0.01 seconds, it throws timeout exception. Okay, so we're going to give 100 milliseconds, which is 0.1, and if that array is not created in 0.1 of a second, it's going to catch the exception here. All right, so we'll run it last time. Our list has been created. Now, it might be different on your machine. I am Iggy. Okay, so it's working fine. Now, so of course this is imperfect. All right, so that means if we have a couple of services running, so this is one service, it's going to keep going until it's going to keep going for 100 milliseconds. Anything more than that, it's going to generate an exception. All right, and we can have other tasks here. So I can go future integer my submit to is equal to service dot submit. This is going to be a callable, so it and it's just going to add up two numbers, 2 plus 2. Okay, so that will not be attempted until 100 milliseconds have passed. Okay, so then I will go my submit to dot get so my submit dot get 100 timeout milliseconds. That's going to wait 100 milliseconds to see is that being created. Okay, it hasn't been created. That's going to generate an exception, and that would also mean that our second task would not be added. Okay, this is our second task. Now, notice how the second task refers to a different sort of future object. Each of your tasks can be completely different. This one deals with this deals with a submit that takes a runnable. This deals with the submit that takes a callable. All right, so this is a submit. A runnable. This is submit with a callable. So each one of your tasks can be different. Okay, it can all be different. So this thread has got two tasks. It's got, this is the first task. It submits that has a runnable. Okay. Then my submit.get 100 timeout. So it's going to wait 100 milliseconds before it gets a value. Now, if it doesn't complete in that particular time, it's going to generate timeout exception. Okay, now that's not perfect. All right, that is far from perfect.
So if you generate timeout, second test won't.
No, won't. Okay, no, it won't. All right. So, no, it's the same thread. Same thread. Okay. Future object refers to a task. Okay. So future object.
So yeah, it's using the same thread.
Yeah. So future object refers to a task. So these are tasks that are on thread. So a thread can have many future objects. All right. Yeah. So future object refers to a task. So there's our two tasks. So what we've done there is that after the first task, it's going to wait 100 milliseconds to see is it fully completed. Now, obviously, that's not a good solution. All right. Main reason it's not a good solution is that if it takes more than 100 milliseconds, what happens? Your second task doesn't run. Okay. So there is a couple of things they can try to do. All right, so that's static void ex5. So next one is static void ex6. Now, so this is submit with sleep, it's called. All right, so again, we're going to do the same shit again. This guy. And I put it in here. Ah, fuck you. So it's this, that, Control C, Control V. All right, so there's our service. All right, now, so I'm going to put in a try block. And we're going to catch. Now, the reason we put in this catch is because we're going to be using dot sleep, and dot sleep can throw an interrupted exception. An interrupted exception is a checked exception. So if something can throw a checked exception, you have to put it in a try catch block. Okay, so that just catches the exception, and we have to file it in to close off the service. And it's finally. So catch exception, system out println E, finally, if service is shut down, service.shutdown. Okay. Now, so we're going to use a different form of submit. So there's three submits. We've seen the submit with the runnable. We've seen the submit with the callable. And there's another submit. So if I go service dot submit, so it's this one. Right. Okay. It's not this one. Hold on. So we go. So. So we're going to put inside here thread dot sleep, and we're going to sleep for 1000 milliseconds. Okay. Yeah, do you know what? I'm going to leave that for now because I don't know what I've done here. Okay, so I'm going to leave out static void ex6 because I don't know what the fuck I've done here. All right, so I'm going to leave out this one entirely. I will come back to it because I have to look in the book. So I'm going to leave out static void ex6. So I'm going to leave that out for now, and I'm going to go straight on to static void ex7. All right, so. Right, so now this is one way that I haven't figured out yet how to delay your thread from execute when it shouldn't or given it a certain amount of time. All right, now there's another way of doing it. This way, I don't know, I've done something wrong with it, I can't figure it out, so I'll have to come back to it. So this one, static void ex7. All right, so I'm going to do executor service again. Now, I'm going to go try. So I am going to go service.submit, and this is going to be a callable, or this is a runnable. So I'm just going to simply go and calling first submit. And you can even do service.execute. So you can have submits and executes. You don't have to have all the one type. Okay. So service.execute. So that takes a runnable. And we can go calling first execute on same thread. And then we're going to have another service. So I'm going to this a future object of type integer, and I'm going to call it foot int is equal to service dot submit. It's going to take callable, and it's going to take in nothing, and it's simply going to add up two numbers. And then I'm going to say foot int dot get. All right, so that's the first task. It's the second task. It's the third task. So this one here, this is submit using runnable. Second one is execute. Can only use runnable. And the last one here, submit using callable with type integer. Okay, so this is an integer, so that means that this guy here has to produce an integer. Okay, now, so everything runs fine, hunky-dory, grand, right? So I put in a final. And we can say we go if service dot is shut down, we go service dot shut down. Now, so oh yeah, 14.get. I have to put in a catch block because that could produce an exception. So exception, sorry. Right. Now, so after all this, we want to make sure that everything runs. Okay. So we make sure everything runs. Then we shut down the service. And then as we're shutting down the service, we're making sure that the threads have fully terminated and have fully returned the results. All right. Now, what you can do is the following. All right. Now, you need to put this after the finally. So you can say if service is not null, which is I'm going to use here. Okay. I go service dot await termination. Okay, so I am going to wait a time period of 10, and it's going to be time unit dot seconds. Now that should be up. Try it up here. Right. So I'm going to put it here. So if or if services is shut down, if it's not shut down, okay, so it gets to here, and then when it gets to here, it waits 10 seconds. So what that does is blocks all tasks that have completed execution after shutdown request or the time. Okay, so it waits for all of the processes, all of the services, all of the threads to terminate. How long does it wait? It waits 10 seconds. Okay, it waits for that guy, and that guy to finish. How long does it wait? It waits 10 seconds. Now, what happens if, now it's not tied to one particular task, this is tied to the whole thread. All right? So it waits 10 seconds after the last one to make sure that all of the tasks have completed in the thread. All right? So that is much better than the previous one because that only waited a couple of seconds after a particular task. What this does is this waits at the end of all of the tasks, and then it tries to make sure that all of the tasks have been completed. If all of the tasks are not completed, it will generate a timeout exception. Okay, so what does that do? This waits for 10 seconds after the last task. Sorry, this 10 seconds after all the tasks should have completed. If they are not completed in this time, it will generate a timeout exception. Now, that is much better than the alternative, because what can happen if you don't have this sort of thing structure? It could run, but it could be producing an answer from the middle of the first task, which could be producing an answer from the middle of the second task. And then the third task is getting answers from the middle of the first task and answers in the middle of the second task, and it's applying them to the third task. So it could throw your calculations completely out and you wouldn't see any error. Whereas with this one, it makes sure that all of the tasks have run to completion, and then it waits 10 seconds after. So they should have all completed by that time. It basically waits 10 seconds after the last task. That's it. Okay, and all of them should have completed after that guy there. So 10 seconds after that guy. So it should wait 10 seconds before everything prints off. So if I go down here, if I put in my final, it should be 10 seconds before that prints off. This is EX7 main. So still running, 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 still running. Finally runs 10 seconds. Now this all leads into scheduling. Okay, so you can see you can wait a period of time. It's the same principle that's going to be involved in scheduling. All right. Now that's us finished for today. Okay, so I'm going to stop that video.